Hello there, and welcome to the video on how to evaluate the definite integral from 0 to pi over 4 of tangent cubed x secant squared x dx. Now, when working with this definite integral, we're going to use the fundamental theorem of calculus. And the fundamental theorem of calculus says if you have a continuous function on a closed interval, then the definite integral from a to b of f of x dx is equal to finding an antiderivative for f of x, and we'll use the notation of capital F for the antiderivative. Evaluate that antiderivative at the upper limit of integration b minus evaluate that antiderivative at the lower limit of integration a. So here what we want to do is to look at our work to find our antiderivative f of x. Now, looking at that, we can do the indefinite integral of tangent cubed x, and we're going to write that as tangent x to the third power, and secant squared x dx. And the reason that I chose to rewrite an equivalent notation for the tangent cubed x as tangent x to the third power was that it helps us to see our u substitution a little bit better. Now notice when we're doing our u substitution, what we let u represent, we also need to have the differential du at least within a constant multiple. And if you notice that if I would have chosen secant x as my u, its derivative is secant x tangent x. But choosing tangent x as my u, its derivative is secant squared x, which we have in the integrand. So we are going to let u represent tangent to x, that amount that's being acted on, and also what we have the derivative of in the integrand. And then our du, well, the derivative of tangent x is secant squared x, and it's the differential, so we'll say secant squared x dx. Now, when we make our substitution, our u is tangent x, so we're going to put u where tangent x is. And our du is secant squared dx. So we are going to replace the secant squared x dx with the du. So now we have our integral of u to the third, and remember the secant squared x dx all goes out with a du replacement. Now integrating that, it's a letter base to a number power, and the number power is not -1. So using the general power rule, we'll have u to the power 4 divided by 4, and then plus our arbitrary constant c. And I can write that as 1/4 u to the power 4 plus c. And then going back to the original variable that we had, u, remember, is the tangent x. So we are going to write this as 1/4 tangent to the power 4 of x, and then plus c. Now from the fundamental theorem of calculus, we just need to have an antiderivative of f of x. So we can choose the antiderivative to be the one whose arbitrary constant is 0. And we'll get that our antiderivative for our f of x is capital F of x is equal to 1/4 tangent to the 4th of x. Now let's come over and do our definite integral. So we have the definite integral from 0 to pi over 4 is of our tangent cubed x secant squared x dx. We are going to evaluate our antiderivative at the upper limit of integration. So putting the pi over 4 in first, minus at the lower limit of integration, putting in the 0. So we have 1/4 tangent to the power of 4 of pi over 4 minus 1/4 tangent to the 4 power of 0. Now again, remember that power 4 means we have 1/4 times the tangent of pi over 4 to the 4th power minus 1/4 the tangent of 0 to the power 4. And then simplifying this, the tangent of pi over 4, well, the tangent of pi over 4 is 1, and I'm raising that to the 4th power, minus 1/4 times the tangent of 0 is 0. And 1 to the 4th is 1 times 1/4 is 1/4, minus 0 to the power 4 is 0 times 1/4 is 0, and 1/4 minus 0 is 1/4. And that gives us our value of the definite integral from 0 to pi over 4 of tangent cubed x secant squared x dx.